We're going to look at some examples of taking those 5 basic rules and kind of just extending it and looking at what happens in certain special circumstances. So first I want to talk about what happens when there's parentheses, or what happens when there's polynomials. So I'm actually going to do polynomials first. We kind of already had a little bit of a discussion of this when we just talked about basic rules. We talked with our sum and difference rule that when you have polynomials, things that are added or subtracted term by term, you're going to derive them term by term. And so these are just a couple quick examples of that. So for our first one, our first term derivative, power out front, power 1 less, is going to be 9x to the second. Now you're going to want to rewrite anything that has a radical. So you're going to want to write that as a 1/2 power. So then again, power out front, the 1/2 and the 2 will multiply to get just 1. Power 1 less is going to be negative 1/2. Derivative of 6x is just 6. And then the derivative of negative 4 is gone. The one thing that I will ask, I really prefer to not have negative exponents. So we're going to write this middle term as 1 over x to the half, or you could write it as 1 over the square root of x plus 6. I won't make you get a common denominator to do all of that algebra, but just the real quick getting rid of negative exponents. Next one. So our derivative term by term, derivative of 4x to the third is 12x to the second. Power out front, power 1 less. Derivative of 3 sine x is going to be 3 cosine x. Derivative of negative 2 cosine x is going to be, actually the negative will cancel with the negative of the derivative of cosine is negative. So you're going to end up with positive 2 sine x. And then the derivative of 5 is 0. So we do not need to write anything. So those are just kind of, again, term by term, and you can have a mixture of trig mixed in there, especially now we're just kind of getting the basics of sine and cosine. If you have polynomials that have parentheses, we really want to try to do as much algebra simplifying as possible before we derive. So that could involve, like this one, distributing. So if I can distribute what's in front, so I get 3x to the third plus 6x to the second minus 12x, that allows me to then derive term by term. So you want to try to eliminate parentheses using your algebra skills. So power out front, power 1 less, power out front, power 1 less, and then the derivative of negative 12x is negative 12. If it is just a single term all to a power, you want to square it out, or if it's to the third power, cube it out. You want to multiply it out. So 3 squared is 9. X to the power to another power, you multiply. And then my derivative is power out front, power 1 less. If you have that parentheses and the power in the denominator, you want to do a couple things to rewrite it. First, you want to square out the bottom. So you get 1 over 9t squared. If you don't like the variable t, you can make it an x. And then I'm going to take that a step farther and write that as 1/9 t to the negative 2. And that allows me to use my power rule. So my derivative, power out front, negative 2 times 1/9 is negative 1/18. And then power 1 less is the negative third. And so the way I'm going to write it in the end, kind of takes a while to get there, is I'm going to write it as negative 1 over 18t cubed. Now, there are other things that could happen. I'm not going to go through full examples, but you could have a situation where you have to FOIL. So you could have a situation where you have a binomial times a binomial and you have to FOIL it out. You could have even like a bigger extended distributing, but all of these things are examples of using algebra to get rid of the parentheses. If you have a numerator that has a bunch of terms and you have a single term denominator, a couple ways to do this. I call this pretzeling. I have no idea why I started using that terminology, but you can split each piece into its own part of the pretzel, and you can take each piece in the numerator and divide it by that x in the denominator. You cannot reverse pretzel. So if you have a denominator that is made up of multiple terms, you can never split a denominator up, but you can split up a numerator. So when you do that, x cubed divided by x is x squared. 2x squared divided by x is 2x. And then x divided by x is 1. So you kind of create 3 separate pieces, and you might have messier pieces. These are pretty clean. And then you can derive term by term. So the derivative of x squared is 2x, and the derivative of 2x is 2. So it kind of gives you a little leeway of how to deal with a numerator and a denominator. And then finally, you're going to have a decent amount of questions that are going to ask you to go further than just derivative to find either slope of the tangent line, or the equation of the tangent line. So if they ask for slope or tangent line equations, you are going to need a derivative to help you find slope. So the derivative of 2x squared plus 3x minus 1 is 4x plus 3. And then you have to be given an x value to plug in order to find the slope there, because you're finding the tangent line or the slope of the tangent line at that value. So when I put 1 in, I get 4 times 1 plus 3, which is 7. That's your slope. Now, the other thing that you need, and sometimes it's given and sometimes it's not, is you need your y value because you need to have a full point. If they give you the entire point, then they save you some time. If they don't, then you have to plug in your x value into your equation to get your y value. So when I plug 1 in, I get 2 plus 3 minus 1, I get 4. If they don't let you use a calculator, they tend to work with really easy numbers to plug in, whole numbers, small numbers. If they let you use a calculator, they can give you messier values. So now to write the equation of the tangent line, we're going to do y minus my y value equals my slope, and then x minus my x value. And I actually prefer if you leave it in point slope, just so if they get a little messier with the slope or the point, you don't have to worry about cleaning it up. So those are some of the extra things that will happen in 2-2 that you have to be comfortable with.